Alright, I figured we might get a question or two on inverse functions, so let's have a look here. Explain why f of x equals x squared take 4x plus 3 is a function but does not have an inverse function. Well, you could get your calculator out and draw it, but I reckon this one's actually easy enough. If we have a little think about it, we'll be able to see what it looks like pretty quickly and easily. So here's y and x. Okay, so this function is a parabola, and if we factorize that, you'll recognize pretty quickly. I'm sure you can all do that factorization. X take 3, x take 1. That it's a parabola with intercepts at 1 and 3. So there's 1 and 3 roughly, and the parabola is going to look something like that. Let's just label it f of x. We'll do the whole lot. X squared take 4x plus 3. Now we talked today about the fact that we remember a function, we use the vertical line test. If there's any x that has more than one y value, it's not a function. What happens with an inverse? The x and y coordinates get swapped over. So, rather than doing a vertical line test, we can do the horizontal line test. If a horizontal line touches the graph in more than one place, as obviously it does, we can even see there with the x-axis touches it at 2 places, it touches it at 1 and 3, then when I find the inverse, this value when x is 0, mapping on, when x is 1, I can get 0, and when x is 3, I get 0. When we do the inverse, that means when I put 0 into the function, I could get 1 or 3 out of it. And that's obviously going to break our vertical line test. But you don't need to worry about finding the inverse and doing it. You can just do a horizontal line test. If I do a horizontal line test, there's more than one x going to that y. So when I swap the coordinates, find the inverse, there'll be more than one y value for the x, which is no good. So explain why part B part 1. I know this is only about B part 2, but for those who haven't seen the leading questions, it's probably worth just going over this. Why does g of x equals the same function where x is greater than 2 have an inverse? Well, if we have a look at what g of x would look like, it's going to be pretty much the same function, except it's going to start, if I can find where my cursor is, there it is, it's going to start there and just be that part of it. So hopefully that comes through okay. You can see the blue and the red section. So starting at the minimum, where x equals 2, we can see that I've only got now the right-hand bit. So when I find the inverse, when I reflect that, well, it hasn't broken the horizontal line test, so it won't be breaking the vertical line test. Let's find the inverse of g of x. Now, remember we can do this algebraically. So for the inverse function, g negative 1 of x, what do we know? We know that the x and the y have to swap in this, or the g negative 1 of x has to swap with that. So I would say x equals g negative 1 of x squared minus 4 times g negative 1 of x plus 3. That's the new equation. How do we rearrange that to try and get g negative 1 of x on its own? Well, let's start by subtracting 3. We're on our way to trying to get this g negative 1 of x on its own, but we've still got a little bit of difficulty there, don't we? Where are we going to go from here so that eventually we can get g negative 1 of x on its own equaling that? What is it that we're going to do now? And the fact is, this is pretty tricky here, isn't it? Because if I factor out g negative 1 of x, well, I'm going to have another one as well. Plus I don't have it equal to 0. So you have to think back to year 10 and something really sneaky that we did that would help us get all those g negative 1 of x's in one term. And what we want to do is one of our favourite things to do in year 10, which was, if it's a quadratic, what could I do? I could complete the square. If I make it a perfect square, Then I'm just going to have g negative 1 of x plus or minus a number, all squared. I can square root and move on from there. And we'll be allowed to square root in this case because we're only dealing with the positive side of it, aren't we? Let's see what it's going to look like. So to complete the square here, I've got my first part, g negative 1 of x squared. Remember now, you want to get it in this form. Let's just do a reminder. A squared, this is minus in the middle, so it's going to be minus 2ab plus b squared. That would then factor into a minus b all squared. So let's go ahead and do that. G negative 1 of x squared minus, let's rewrite this middle term in this form. So it's going to be 2 times g negative 1 of x. What's the other term? We've got the 2, we've got our a, b is the term I'm missing. It's still got to equal this. It's still got to equal negative 4 times that, so it must be a 2 that I'm missing. So in order to complete the square, I need to add on 2 squared. But of course I can't just go adding on 2 squared to something unless I compensate by either adding 2 squared on the other side, or because when we factorise we need to do it all on one side, I still like to do it as minus 2 squared on that side. So I've added 4 and subtracted 4 basically. But what that's enabled me to do is I've now got something that's in the form of a perfect square. So we've got something that's in the form of a perfect square. We can now go ahead and factorise more easily. First of all, what do I need to do? This negative 2 squared, that's negative 4. I'm going to add 4 to each side. So the left-hand side is going to become x plus 1. This term inside those red brackets, the perfect square, I can now write as g negative 1 of x. So that's my a from this expression, minus, what's the b? What's equivalent to b in that expression? It's just the 2, isn't it? So g negative 1 of x minus 2 all squared. The beauty of that, now I can square root each side. Is it okay to square root this time? Yes, because I've restricted my domain, so I'm only going to need the positive square root, so I don't need to worry about plus or minus. I only need the positive square root there, and that's equal to g negative 1 of x minus 2. Now I add 2 to each side, and that's where they get 2 plus the square root of x plus 1 equals g negative 1 of x. So it's a pretty challenging question, but hopefully a bit of fun for you. You can see how they got that. That completing the square, it's not overly intuitive, particularly the first time, but hopefully now you've seen it, maybe if it comes up again, you'll be able to do that yourself too. Keep up the great work, guys. Bye.